factor here, and we can't do that until it's equals to 0 on one side. So I bring over the 15, and then we've got greater than 0. Now, if you guys and girls still remember from your add maths, we got to use a table value, or we've got to sketch the graph to solve these inequalities. So let's first factorize. We've got x and x. 3 and 5 gives us 15. We want to get a minus 2, so minus 5 plus 3 gives me a minus 2. So then moving on to the, I'm just going to use a graph. Now, look at this guy here, x squared. In other words, this is a positive x squared, so it's a smiley face. So we have a smiley face graph here, cutting at minus 3. Remember this, you have got to reverse the sign, because when we look for the root, is x plus 3 equals to 0. So x equals to minus 3. And over here, we have got x minus 5. Don't forget to reverse the sign. This is quite a common mistake. Some guys and girls do it too quickly. So you just take it as positive 3 and negative 5. And then we just got to shade the region. Now, this inequality is greater than 0. So this is actually, we are corresponding to the x-axis. Anything above here is plus, and anything below the x-axis is going to be a minus. So since we are looking for greater than 0, the shaded region is on this side above, and also this is above the x-axis. Now, how do we get the set of values? So we've got minus 3, and the shaded region is towards the left. Numbers that is towards the left is getting smaller, and this shaded region is towards the right, so it's getting greater. So we have set of inequalities as x is less than minus 3, or x is going to be greater than 5. So this is going to be the solution for part 1. And then for the second part over here, they're asking us to find the range of f and state with a reason whether f has an inverse. Before that, any questions on the first part? If no questions, I'll move on to the next part. So most of you guys and girls would remember this. So moving on to the second part over here. Now this is quite important, where they state with a reason if f has an inverse. So to get the range for f of x, again we have f of x equals to x squared minus 2x over here. We got to complete the square since it's quadratic. So we have x minus 1, the whole thing squared, minus with 1. So therefore, we have the range of the function f of x or y has to be greater or equals to minus 1. Now, if I were to draw a simple sketch over here, we know that this is going to be a smiley face graph, x0, y0, cutting through the origin. It's going to go down here, cut through 0, 0, and turn back up. And the turning point, you see inside the bracket. So this one, just a refresher for those who have forgotten, you got to flip the sign of inside the bracket for the x. So x equals to 1. And the guy outside here is your minimum point for your y directly. You don't have to flip what's outside the bracket. So what we have here is x equals to 1. And the corresponding minimum point here, y is negative 1. So if I were just to put some arrows here, this is this point here, and x equals to 1 is the x coordinate over here. So that is why the range is greater or equals to minus 1. The lowest point the graph will reach is go down up to -1, and then it turns. So range is your y-axis, so anything above or equals to -1 is valid. Now state with a reason if f has an inverse. This is easy by just looking at the horizontal line test. Anywhere on this graph, if I draw a horizontal line, cut more than one time. If it cuts more than one time, it's not a one-to-one function, so no inverse. So the answer with this for this would be no inverse, since f of x is not a one-to-one function. And then we want to move on to show the expression of g f x equals to 0 has no real solution. So let me just clear the page over here. So again, we have got, sorry, let's just put that in. So over here, let me just rewrite the question. We've got f of x equals to x squared minus 2x. And we have g of x equals to 2x plus 3. So if you want to find g f of x, we've got to input the fx function into my g. So g, we just rewrite, and my fx is the quadratic function here, which is x squared minus 2x. So according to the rule of function, this replaces into the function of g now. So we've got 2 into x squared minus 2x, and the constant we just rewrite, there is a plus 3 over there. So expanding the bracket, this gives us 2x squared minus 4x plus 3. Now they want to say that this equation equals to 0 has got no real solutions. So we have g f x equals to 0, implying that 2x squared minus 4x plus 3 equals to 0. And how do we test if a quadratic function has got a real root or no? Or not? So we have to do b squared minus 4ac. Check the discriminant. My b is going to be minus 4 squared minus 4. A is 2 and my c is 3. So over here we end up getting 16 minus 24. So over here we have a minus 8. Now that's not so important, the 8 value. What's important is this negative value. As long as it's less than 0, we have no real roots. So no real roots means this guy got no solution. So what does this mean if I were to draw just a diagram? I mean, this is not the graph of my GFX. I'm just drawing a graph that has got no real roots. That means the graph turns. Before it touched the x-axis, it already turned up. Because a root is where the graph intersects the x-axis. This point and this point, so these are called the roots. If your b squared minus 4ac is less than 0, the guy has already turned back before it can reach the x-axis. And then finally over here, they've got the graph of gx. Now let me put the graph on a scale here, and then I will show you guys on the whiteboard. coming. Just give me a moment over here. The graph is loading. Okay, so if I were to clear the screen and put up the graph now. So this is how the graph is going to look like. Now, if you see carefully, the graph of gx is 2x plus 3. So the graph in red here is y equals to 2x plus 3. It's quite evident because see the c is 3 over here. And then the graph in the green here is going to be the inverse. So this is the inverse of 2x plus 3 is going to be x minus 3 over 2. Now, for you guys, if you've forgotten, how we do that is we flip it. So we've got 2y plus 3 equals to x. We have 2y equals to x minus 3. So y equals to x minus 3 over 2. So this is my g of x. And this is my g inverse of x. If a question requires to make clear the relationship between g of x and g inverse x, you got to draw the blue line here, and this line is y equals to x. Because the inverse function is a reflection, g inverse is a reflection of g on the line y equals to x. Okay, fungsi songsangan adalah pantulan fungsi asal pada garis y equals to x, and this is a fixed thing. Any function, the inverse is a reflection about the line y equals to x. So once you draw this, you get all the 2 marks here. And in your exam, I'm using a software over here. This line in blue, usually we draw in a dotted line. We don't draw in a solid line. A dotted line to show that this is the line of reflection over here. Any questions so far, guys and girls? No questions. So I'm going to clear the board now, and then we're going to go to the next part. So number 2 over here, we have got another function where we have f of x equals to two x minus a. Now in the first part, they already tell us that a equals to 3. So what we got to do here is we just take this a equals to 3 and put it into the original question. So that gives us f of x equals to 2x minus 3. And then they say the composite function, fungsi gubahan, f x equals to 11. So we have f of x equals to 11. What's the meaning of f x? The meaning of f x is we replace f of x into itself. So we have got 2x minus 3 here, and that equals to 11. So how do we do this? Whatever is in the bracket of f, we replace into the original fx. So I've got 2 into 2x minus 3 equals to 11. And then expanding, we have got 4x minus 6 equals to 11 over here. Hold on. The constants don't change. 2x minus 3, this guy here still remains. Minus 3 equals to 11. So we have that equals to 11. Then we have got 4x minus 9 equals to 11, giving us 4x equals to 11 plus 9 is 20. So solving gives us x equals to 5. So that's for part 1. And then in the part 2 over here we have gx equals to x squared, and then we have got a for f of x equals to g of x equals to exactly one solution over here. So I'm just going to take some space over here, and then we're going to do the part 2. So f of x equals to g of x. So just follow the instruction. Take your f of x function. F of x is going to be 2x minus a, and make it equals to your g of x function, which is going to be x squared minus 6x over here. And then we have got x squared, bringing it all over to one side, giving us minus 8x plus a equals to 0. And now they say has only one real solution. What does it mean only one real solution? The condition is the discriminant b squared minus 4ac has to equals to 0. So we have got minus 8 squared minus 4, a is 1 and c is going to be a equals to 0. Expand the brackets. So we have 4a equals to 64 and a equals to 64 divided by 4, giving us 16. Now, this is, I'm not saying that all students make this mistake, but usually students rely upon their calculator a lot. Simple things like this, do not press minus 8 squared in your calculator. You will get the answer as, what do you call this? You will get the answer, if you just press it like this, it will give you minus 64 over here. So you see, when I'm writing also, I make it a practice to put a bracket. In your calculator, if you press minus 8 in brackets with the square, this is the correct answer, which will give you 64. Simply because your calculator computes without the bracket, this means it's actually minus 1 times with only the 8 is squared. So this is minus 1 times 64, and that's why your calculator will give you the value of minus 64. So if you want to tap into calculator, make sure you use the brackets, and then you'll get the correct value over here. So moving on to the next part. Okay, so here we've got a quadratic function, and then they have restricted us. Okay, there's a reason why they restricted us. I believe most of you guys should know why. The domain is x is bigger or equals to 3, but I'll still explain it in case some of you guys or girls have forgotten. So we have h of x equals to x squared minus 6 of x over here. So you look at the form that they're talking about here. X minus p and the square is outside the bracket. By looking at it, you know they mean they want us to complete the square. So we have x squared minus 6x equals to open bracket. The coefficient of x divided by 2 giving us 3 square over here, and then minus 3 squared is minus 9. And that's it. So this is what I meant why they gave us the domain as x is bigger or equals to 3. Because in the next part, they ask us to find the inverse function. So this is my turning point. X minus 3 equals to 0. So x equals to 3. Now, because they ask us the inverse function, they have restricted the domain. Otherwise, the question will be wrong. If I were to sketch this graph, we're going to have when x is 0, y is 0, and then we have a graph passing by the origin, going all the way down to -9 and turning up. So this is what I meant by the point 3 over here. And the lowest point here is -9. So when they say the graph is only valid for x greater than equals to 3, anywhere before 3, I erase the graph. Bahagian ni harus dipadamkan. So sekarang, if you draw the graph over here, for x greater or equals to 3, we have a curve starting at -9, going up, 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 up. So this is 3. And there you go, guys. This is -9. Now, why is this important? Earlier, we said only one-to-one function got an inverse. Over here, before I padam the part in red, if I draw a straight line, I cut at 2 places. This is not a one-to-one function, so no inverse. But when x is greater than 3, anywhere I draw a straight line, only cut the graph at 1 point. So this is a one-to-one function, and then we have an inverse over here. So you see the next part, they're asking us to find that inverse function in part 4. Since it's a one-to-one function, the inverse exists. And how do we find that? Do not use this guy over here. You cannot find the inverse. We use the completed the square form, because over here in the box, I only have got one x value. So the standard step will be change x to y and y to x. We've got y minus 3 squared minus 9 equals to x. So we want to make y the subject. I have y minus 3 squared equals to x plus 9. Y minus 3 equals to the square root of x plus 9. So giving us y equals to 3 plus with square root x plus 9. And do not forget, so we label this back as the H inverse. H inverse x equals to 3 plus square root x plus 9. And then you see the question, they ask us to state the domain of H inverse. This one, students, any pelajar-pelajar, you guys got to pay attention. I just move on to the next page for a bit. I want to make a note here. Very important, the first guy here, domain of my f of x equals to the range of f inverse x. So buat nota sendiri, make some notes in your own words, or just write it somewhere as a key point. And then the range of f of x equals to my domain of my inverse function, or f inverse x over here. So moving back to the other screen, from the graph I sketched over here, what is my range? This is my graph. Tadi yang ni, this is the graph of h of x. So the range of h of x is y is greater or equals to -9. This is my range. But if go to my inverse function, it becomes my domain. So my domain over here, the range become domain, domain become range. So just change the y to become x and you're done. Any questions so far on this concept? Okay, no questions so far. Now moving on to number 3. As you can see, when we go to number 4 and 5, it's more important because we have got trigonometric functions coming there. So up to number 3, most of you guys can use even your maths knowledge and pretty much solve this. So 3 part 1, we got sketch on a single diagram, making clear the relationship. Just give me a moment here. Let me sketch this for you guys. Okay, so I'll just clear this board first and just explain to you all how the graph looks like. So now that's how it's going to look like. So the first one is f of x. And look at the function of f of x. By looking at the function of f of x, we have this guy got to be f of x. Y equals to f of x. And then this is the reflection line, always standard, like I mentioned earlier, y equals to x. In your exam, if you're required to draw this, please draw it as a dotted line. The graphing tool here, just put it as a solid line. And this is my inverse, y equals to f inverse x. Nampak tak? You guys can see, guys and girls, that again, the inverse function is a reflection about the line f equals to x. Now, just by looking at this blue line, I knew this is f of x because f of x, the equation is given as 3x minus 2. See, this guy here is your c, negative 2. So the blue line is fx. Obviously, the other line is f inverse x. I'm not going to recalculate this, but if you guys calculate the inverse function, you should get x plus 2 divided by 3 as your f inverse of x. So that's the first part, fairly straightforward. And then for the next part, more calculations involved. F of x equals to 3x minus 2 over here. And we have g of x equals to 6x minus x squared. So they want us to show the maximum value of g of x is 9. So let's find g of x first. So g of x means putting f of x into g. So my fx is 3x minus 2. And wherever I see an x in my gx, I got to input. So this x also becomes 3x minus 2. And the x over here also becomes 3x minus 2. So what we got to do now is just expand the brackets over here, giving us 6. 3x minus 2 minus with 3x minus 2, the whole thing squared. Expanding bracket gives us 18x minus 12 minus, maintain brackets first. So we have 9x squared minus a 12x and plus 4. Let's open up all the brackets. Plus 12x minus 4 over here. So by simplifying this, we have minus 9x squared plus 30x. That's a 4 there. So minus and minus, we have a minus 16 over here. I got to complete the square for this guy now because they asked us to show that the maximum value. So before we complete the square, we always pull out the constant in front of the x squared, in this case, which is a negative 9. So I'm left with x squared. This becomes a minus. I've got 10 over 3 here, x. Now at this point, guys and girls, I not yet start completing the square. What I did is merely just factorize. If I times minus 9 into here, I get minus 9x squared. If I times the negative 9 in here, minus and minus gives me a plus. 9 and 3 cancels off to give me 3 times 10 give me 30x. So I not yet start completing the square. The next step only we start completing the square. So we open a big bracket, x, 10 over 3 divided by 2 giving me 5 over 3. Square outside the bracket always minus. 5 over 3 squared is 25 over 9 here. And then minus 16. Bringing in the minus 9, we have x minus 5 over 3 squared. And then minus and minus plus. 9 times 25 over 9, 9 and 9 cancel, gives me just a 25 minus 16. So let's continue over here. This is minus 9 into x minus 5 over 3 squared. 25 minus 16 is 9. There you go, guys and girls. This is what we are looking for. Because as I told you, guys and girls, what is outside your bracket is your y value. So if I were to draw this graph, or just rather a rough sketch, so we have a sad face. How do I know that this is a sad face? Look at the coefficient of x squared here. It's a negative x squared. Just by looking at the negative sign here, I know that the graph has a sad face. x0, y minus 16. So this graph is going to go up and then come down like that. So we have minus 16 here. Inside the bracket, this sign we always got to flip. This is a negative, so it becomes a positive 5 over 3. And look what happened over here. Outside here is the 9. And what did the question ask us to show? Show that the maximum value is 9. We have shown that because we obtained a 9 here. The graph goes up to 9, highest maximum value, and then it turns down over here. It cannot exceed number 9. And then moving on to the next part. We have h of x over here equals to 6x minus x squared. This is quite a typical question asking us to complete the square again. So I'm just going to rewrite the x squared term here. Plus 6x. Take out the negative. Minus 6x over here. And then negative, open the big bracket and complete the square as usual. Coefficient of x dividing by 2 gives us 3. Square outside the big bracket, minus 3 squared is 9. And then we bring in the negative here and here. Minus and minus 9 giving me a plus 9 minus x minus 3 squared. So we've completed the square for that. And once we completed the square, see the last part, they follow us by asking what is h inverse x equals to. Why? Again, to find the inverse function, we got to use this guy and not this one here. Because over here, I've got x and x squared. I can't make x the subject. Whereas when I completed the square over here, I only got 1x inside here. So as usual, we have 9 minus, change the x to become y. And make this equals to x. So shift places over here. We have 9 minus x equals to y minus 3 squared. moving over the square, we have square root 9 minus x equals to y minus 3. And finally, moving the minus 3 over, we've got 3 plus the square root of 9 minus x equals to y. And do not forget, replace y with the h inverse of x. 3 plus with square root 9 minus x. So we're done with all the basic functions with question 1, 2, 3. Next, we'll be moving into trigonometric functions. Any questions so far on these composite functions, inverse functions? Anything you guys and girls want to ask me? Okay, so for question number 3, can we not draw the graph to show the maximum value is that? Okay, it's a good question, but for you to draw the graph and show that 9 is the maximum value, you have to go through completing the square. And another thing, you see, this is an examination question. Look at the marks at the side there. It's a 5 marker. So if it's a 5 marker over there, you got to do some algebraic calculation as well. And where you get the marks from? Completing the square. So if you're in SAM 2, now, okay, for SAM 2 students who are repeating, since in part 2, they did not say complete the square to show it's a maximum value, you could also use dy dx equals to 0. So cari dy dx equals to 0, dapatkan nilai x, gantikan nilai x dalam y, and then y akan jadi 9. You'll still get the full marks. Now for part 3, they already ask you to express as completing the square. So part 3, you have to complete the square. But for part 2, to play safe, complete the square or do your dy dx because it's a 5 marker. And all this depends on the marking scheme as well. So the more the marks, the more the working you guys and girls got to show. So to be very safe, show some algebraic calculation, either completing the square or dy dx. And then with the aid of the graph, and you're done. That's the 5 marks over there. Any other questions, guys and girls? Now, again, I've also have, okay. Before we move on, sometimes they ask you a little bit of theory questions. We did quite a bit of composite functions over there. So let's say we have got over here, let me just take an example of here. Let's say we've got a function of gfx, okay? And this is going to be a fungsi gubahan. This is a composite function. So for this to exist, we have the range of f has to be a subset of the domain of G. So that is a condition. Do you understand why we need this condition for the composite function to exist? Any one of you guys understand why this is a condition? Let me give you all an explanation over here. So domain, okay, let's put it in a different way. Let's say domain is an house. So in other words is input. Input is domain and range is your output. All right. So let's say we look at a simple function over here. I have f of x equals to 2x minus 3, and I have g of x equals to 5x minus 2. So let's say I want you to find fg of 1 equals to what? So let's first look at what is fg of x. Fg of x equals to f, and then I have gx is 5x minus 2. So this got to go into my f. I've got 2 input there, 5x minus 2, and then minus 3. So I take my g and put it into my f. So this gives us 10x minus 4 minus 3. So final answer, we have 10x. Something's wrong with the pen. 10x minus 7 over here. Now I can find my f g of, sorry, we got a g first. So now I could find my f g of 1. fg1 means I masuk je satu inside the x here into my fgx. Minus 7. So we have 10 minus 7. And we have number 3 here. Okay, so that's the answer. And then look at something else. I'm going to show you another way to approach this. G of 1 is inside my f. So what I'm going to do first, I'm going to put 1 into my g. I'm going to find g of 1. So g of 1 equals to 5 times 1 minus 2. So this is 5 minus 2. Now follow carefully because the explanation is directly from an example like this. Okay, now I just told you all input is my domain. So this is domain. And output is my range. Nombor yang keluar sini, the number 3 over here that came out, this is actually one of the range values. Every input, the output is called the range. So I found g of 1. Once I put g of 1, I must take this value that came out, the range value, and put it back into f, sorry. First, I do the inside, the value that come out, I put into the outside. So now I must find what is my f of 3. So f of 3 means I ganti 3 into my fx, 2 times 3 minus 3. So this is 6 minus 3, I get 3. There, jawapan sama. 3 here and 3 here. So what do you guys and girls notice by this? In a composite function, I took the 3 here, which is my range value, and I'm putting into my fx. The 3 that masuk over here is my domain. And what is my domain? I told you guys and girls, domain is like a house. If I'm going to enter a house, I got to be a subset of the house. I got to be bigger or equals, I got to be equal to or smaller. If you're going to enter somebody's house, you cannot be bigger than the house, so you cannot enter. So the condition for you to enter, because this 3, the range, is going to enter and become the domain, going to masuk into the x. X value is your domain. So the range value must be a subset. That's why the range of f yang nak masuk tu have to be a subset. Lebih kecil atau sama dengan the domain of G. Sebab dia masuk dalam G sini over here. Otherwise, it is not valid or don't exist. Do you guys and girls understand this? Do you see the concept now? How the range from f enters? Okay, thank you. At least that was clear. A lot of students get confused on this, and you guys got to really get this kind of key concepts. And before we go into trig, I just like to congratulate actually you guys for taking up the course Stpm. A lot of students out there after their form 5, they go in and take a foundation, a 10 months course, FIA course. I was also I've been a teacher for a long time. I've been teaching the form 6. I teach right up to second year universities. And the STPM or the A levels, the Form 6 course is actually one of the most difficult. In other words, the syllabus, you guys and girls actually learn a lot. So I've got a lot of students who enter engineering from foundation and also from STPM and A levels. And believe me that up to 80% of students who enter from foundation, all those short courses, 10 months courses, they end up repeating their engineering maths and so on in university. But with STPM or A levels, you're going in with a solid knowledge. So a lot of people may discourage you guys and girls and say it's a 2 years course, why waste time? Trust me, you're not wasting time. You'll see the difference when you enter into your university course. You're doing a solid pre-university course here. You're not doing a fast course. If you look at the CIMP, I was a CIMP lecturer, the Canadian matriculation program. It's just a 10 months course, and then you enter into university. Their component for calculus only got Pambeza, you only learn differentiation. When you reach SEM 2, you look at the amount of integration you guys and girls got to learn. It's crazy. And for them in 10 months, they don't learn integration at all. And if you're going to do engineering, you will be surprised the amount of engineering integration you're going to cover. So it's very important that you enter with a proper foundation, and you guys are actually doing a very good course over here. So I'm going to clear here, and then we're going to go into I'm going to clear the page up here, and we're going to go into trigonometric functions. This is another topic a lot of Form 5 students, I'm not saying pinpointing that everybody, but people struggle with identities, proving identities, Master Dekat Form 5. So we start off here with number 4. We already see there's some identities involved over here. We've got fx equals to 5 sine squared x plus 3 cos squared x over here. Now, very important, this is a show question. Kalau dia cakap tunjukkan jawapan macam ini, show your question, your answer is like this. In other words, they're already helping you guys and girls. They're already telling you what the answer looks like, So here they're asking you to express fx in the form of a plus b sine square of x. So nampak tak jawapan, the answer does not have a cos squared. It only has a sine squared. So over here, what we got to do is just rewrite what is the identity over here. The basic first identities you guys and girls learn in identities, trigonometric identities is cos squared x plus sine squared x equals to 1. So we're just going to use that, and in a few steps we can show the answer. So I see my answer has got a sine squared. Yang sudah ada sine squared jangan kacau lah. So you just write back 5 sine squared x plus 3. The cos squared I can change. From here, cos squared, I just bring this over. So cos squared I can change to become 1 minus sine squared x. Now everybody has got a sine squared term. So this becomes 5 sine squared x plus 3 minus open bracket 3 sine square of x. So we have 3, 5 minus 3 is plus 2 sine square of x over here. So that's it. Stating the values of a and b. So we have a equals to 3 over here, and we have b equals to 2. Hence, find the value where f of x equals to 7 over here. So we got to press calculator in for this. So for the next part, just a moment, let me get back that into play. So we want to do f of x equals to 7. Don't use the first expression. Pakai yang ini. This is also fx. Cuma ditulis dalam bentuk lain. So we got 3 plus 2 sine square of x equals to 7. And then over here, we have, oh, I rewrote the question wrongly. Otherwise, yeah. Sine inverse 2 got no answer. This is 7 sine x. Sorry, my bad. So we've got bring over. We need a quadratic. This is a hidden quadratic in terms of trigo. Minus 7 sine x plus 3 equals to 0. Sekarang buat pemfaktoran. Normal step. So 2 sine square x will become 2 sine of x. And this is sine of x. 1 and 3. I want to get a minus 7. This is not 1 and 1. This is supposed to be a 3 over here. So 2 times 3 minus 6 minus 1 give me a minus 7. So moving on up here, we have got 2 sine x minus 1 equals to 0. Sine x equals to half. So x equals to, in trigonometry, jaga baik-baik sikit, kena tengok domain. You need to see your domain over here. Is the given domain in degrees or radian? They must give you over here, it's 0 to pi. So it's in radian. So sine inverse half is a special angle, 30 degrees in radians is pi over 6. Sine is also positive in the second quadrant, pi minus pi over 6 giving us 5 pi over 6. So if you press calculator, pastikan mode is in radian. And then the other answer we have, oh, this one tak ada jawapan. Sin x minus 3 equals to 0. Sin x, just put like this, cannot equals to 3. Why sin of x cannot equals to 3? This comes from the graph of a sin x function. Just make a rough sketch over here. This is a sinusoidal curve that has an amplitude. A standard sin x graph goes up and comes down. But what is the amplitude? Maximum it can go is 1 and minimum is minus 1. So this is y equals to sin x. But we have sin x equals to 3. 3 is up here. Kalau you lukis garis ni takkan sentuh graph. If you tekan in your calculator, if you press in calculator sin inverse 3, you will get error. Why error? There is no value here. 3, there is no graph here. If you press anything between 1 and 0, you will get. So our value was half. So what happened when you press half? This was your first value. Pi over 3. Dia potong graph pada dua tempat. And this is your second value yang kita dapat tadi. Sorry, bukan pi over 3. 30 darjah, 30 degrees. This is pi over 6. So this is 30 degrees. This is pi over 6. And then the other answer is 180 minus 30. So this is 5 pi over 6. 150 degrees. Any questions on this? So now we got to look at the range. Always fall back on the graph because range is your y-axis. If you understand how the graph looks like, it leaves a big burden off your shoulders actually over here. So the graph that we want to draw now is the graph of f of x equals to We just take it out here. The simplified 3 plus 2 sine squared x. 3 plus 2 sine squared x. Follow carefully, guys and girls. I'm going to show you all a shortcut here. There are only a few values you need to look at this. Now, a sine x graph I just showed you all goes up to 1 and comes down to -1. So this is 1, this is -1. So standard sine x graph. Follow carefully, it's actually quite simple. I'm going to change the function now. Let's say I have a function fx. I'll come back to the original question, but I put this as 3 plus 2. Instead of a sine squared, I put 3 plus 2 sine x. So, nilai paling tinggi, the sine x, your y is your sine x, you know. So, nilai paling tinggi, the sine x can go on the y-axis is 1. So, I have the max is when sine x equals to 1. So, we have 3 plus 2. Sine x ni ganti saja dengan 1. That's the maximum it can go. So, it will be 5. And the lowest, you see again, sine x ni adalah your y. This sine x is your y. So, the lowest it goes on the y is -1. That means the entire sine x graph, the sine function, you just ganti with -1. And that's it. So, we've got 3 minus 2, and this is 1. So, what is my range here? My range here is the y lies between 1 and the maximum value here is 5. But this guy is a bit different. It's a sine squared graph. So the maximum we just saw is when it's 1. 3 plus 2, 1 power 2, we get 5. Now for the minimum, this is the part that's a bit tricky. You'll get 3 plus 2. The minimum value is -1, but it's a sine squared. You're going to square that. When you square -1, you're going to get a plus. So this becomes 3, and this becomes a +1. Negative times negative is positive. You still get a 5. But what is the other critical part you got to see? 0. The next part you got to see for the minimum is when it's 3, your sign is also 0. The whole sign you gantikan dengan 0, you get 3. So when it's a sine squared graph, the negative and the positive will be the same. Because when you square, the graph is above 0. Sudah naik sini. The graph down here when you square don't have. So now, when it's 0, we have got 3. The range for this function, the original question, you have to use 0. So this is your minimum point. And then you've got y, and your maximum point is 5. This is important concept here. Any questions on this? When there's a square, you see your negative becomes the positive. So your graph is all above the x. Okay, so that part is clear over there. And then moving on to the next question over here, number 5. Is that our last trigonometric question? Number 5. Yes. How we know whether to include or not? Good question. Now, you tengok soalan asal. You look at the original question for number 4 here. Dia dah bagi domain. Domain is 0. X dia dah include both the extreme values until pi. So if they have included from 0 to pi, that means you have to include the value here. Sebab domain dah include. If here they did not include, like this, then you also don't put the include. Always the range kena ikut domain. Sebab domain adalah input. Berdasarkan input, based on the input saja, range output boleh keluar. Can you guys follow this? Okay. And then we move on to the last trigonometric question. Let's move on to number 5. And then just take a 5 minutes break over there, and then we'll come back on factor and remainder theorem. So the next trigonometric question over here, we've got f of x equals to a minus b cosine of x. And what's happening over here, they've given us a domain. Fungsi mesti ada domain. Again, you see 0. They include right up to 360. So this is one full cycle. Now, the main thing before I start this, I'm going to look at this guy here. Minus cos x. Again, to understand trigonometric functions, function always involves graph. You must know what the minus does to the graph. So a cos x graph starts at 1, goes down to -1 and comes back up. So this is 1, this is -1, y equals to cos x. If I were to draw y equals to minus cos x, what happens to the graph? A minus in front of the function means reflection about the x-axis. So that means the graph shape is the same, tapi sudah pantul. Reflected on the x-axis, this is -1, and this is 1, here is 0, same thing, y equals to, but this is negative cos x. See the difference? Now this difference here is crucial. Why? Because they told us maximum value. Max value over here equals to 10. And they told us the mean value equals to -2. So the senior students over here, when you look at here, the mean value for the negative cos x graph, this is pi, bahagi 2. Minimum value di sini adalah negatif 1 dan berlaku apabila x sama dengan kosong, sifar. When x is 0, you get the minimum value. So over here, f of 0 will give me the minimum value yang dia dah berikan sini, will be -2. See, the lowest value happens at 0. So I've got a minus b cos 0. And the minimum value is -2 over here. Cos 0 is 1. If you press calculator in radians, this must be, this must be in degrees. Ini domain dari dalam degree. So press calculator in degrees, cos 0 is 1. So a minus b is -2. We got persamaan nombor 1. And then you look at pi here. This is the negative cos graph because here is minus here. I'm looking at this graph. When pi, I'm getting my highest value. But according to the question, my highest value is 10. So gantikan, just replace. When I put pi into my equation, I will get my maximum value. But given is 10 here. So a minus b, gantikan x dengan pi, equals to 10. If you press calculator, cos pi is -1. You get 10. So over here we got a plus b equals to 10. Now this is persamaan serentak yang mudah. This is a easy simultaneous equation. All I got to do is add them. I take equation number 1 plus equation number 2. Kita dah masukkan b. B has been eliminated because b plus minus b is 0. A plus a is 2a. 10 plus -2 is 8. So giving us a equals to 4 over here. So we got a as 4. Ambil a as 4 and ganti dalam mana-mana persamaan lah. Let's say I just take a is 4 and put it back in there. We've got 4 plus b now equals to 10. And there you go. B equals to 10 minus 4 is 6. So I'm going to put it back in the equation and show you what I meant earlier. I got A is 4 and B is 6, right? So we have over here now f of x equals to 4 minus 6 cos x. Now, the negative cos x graph just now, what was your lowest value? Minus 1, your highest value 1. This is minus cos x. We can check our answer easily if we are correct or not. So, see over here, 4 minus 6. When I input minus 1, I get 4 plus 6, and there you go. 10 is my maximum value. Diberikan dalam soalan pun, 10 is your nilai maximum. And then we've got 4 minus 6. When cos equals to 1, I get 4 minus 6, and we are left with minus 2. In the question, minimum value was minus 2, so I know my answer is correct. Any questions on this? And next, they want us to solve the equation equals to 0. This is back to add math, so we have f of x equals to 0 over here. 4 minus 6 cosine of x equals to 0. 6 cosine of x equals to 4. We have cos x equals to 4 over 6. So x equals to cos inverse. Simplifying 4 over 6 give me 2 over 3. So you got two answers here for the given domain. We got 0 and 360. If you press cos inverse 2 over 6 over here, you will get 48.2 degrees. Cos adalah positif di sukuan pertama dan keempat. What is the rule for the sukuan keempat? 360 minus 48.2. So the next solution, this angle is going to be 311.8 degrees. So I have this equals to 48.2 or 311.8 degrees over here. So this is quite basic, going back to your Form 5, just solving the add maths over here. And then we want to sketch the graph here. We already know the graph is inverted like this. Kita dah tahu graph dia berbentuk sebegini. And then we have 4 minus 6 cos x. We know the minimum is going to be minus 2. I'm going to take some time to explain this guy to you guys, this graph to you guys and girls. What it does, the transformation here is very, very important. So just bear with me over here. This can be tiring, but you got to understand this pretty well. We know a minus cos graph is flipped. What happens if I've got a minus 6 cos x graph? It means the lowest is minus 6 and the highest is 6. So this is a graph of minus 6 cos x. Now when I plus a 4 to this, it means I push up this graph 4 units up. Saya nak tolak graf ni ke atas 4 unit, plus 4. Minus 6 plus 4 is minus 2. And 6 plus 4 is 10. So now the graph going to look like this. My lowest value is minus 2. And the highest value from 6, you push up another 4, you'll reach 10. Betul tak? Same like the question tadi. Soalan pun dah katakan maximum is 10, minimum is 2. Our graph also we got maximum is 10, minimum is 2. And then yang lain tu isikan sendiri. So this is one full cycle. This is 360. And then dividing here at 180. And somewhere around the halfway point here. What is the halfway point of this? This is going to be originally my halfway was 0, so this is going to be 4 over here. So exactly at 4 will be your 90, and the other part here will be 270, and this is the graph of 4 minus 6 cos x over here. Any question, guys and girls? Okay, thank you for bearing with me up to here. It's been a long class. Let's just take 5 minutes. I just got to go refresh myself. And then we're going to go into factor theorem and remainder theorem. Now, the next part we're going to cover is entirely Stpm because we have long division and modulus inequalities together with partial fractions coming up and some identities. So I'll catch you guys and girls in about 5 minutes. So take a break and then see you then. Okay, guys and girls, I'm back here now. Can you all hear me? Okay, so let's move on to the next question today. We're going into polynomials, so the factor theorem, remainder theorem over here. Now, look at question number 6. So they have given us a function here, px. So we have p of x equals to x power 4 plus with 4x squared plus x and plus with an a, and they gave us a factor. They told us that x squared plus x plus a 2 is a factor of p of x. Now, notice something about the factor given. We can't split that. We can't factorize that into two brackets unless use the quadratic formula. And if you check your b squared minus 4ac, you're going to get a complex number. Kita belum masuk bab complex number. So indirectly what the question is doing here, it's forcing you guys and girls to do the long division over here. You have to do pembagian panjang lah, long division. So since it's a factor, I know my remainder has to be 0. So let's perform long division over here. When we divide by a factor, we must have 0 remainder. Just like 4 is a factor of 8. If I take 8 and I divide by 4, I must have 0 remainder. So they told us that x squared plus x plus 2 is a factor of px. Therefore, when I long divide, I must have 0 remainder. Notice I do not have x cubed. So put a 0x cubed so that you don't lose track of the terms. We have an x squared. We also have an x term, and we have a constant term a here. And then I'm going to long divide all this with x squared plus x plus 2. In order to obtain an x power 4, I need an x squared over here. So I have x power 4 plus x cubed plus with 2x squared. Minus, do not forget, if you watch my video on YouTube, I keep on telling you guys and girls, open bracket and put a minus outside. So we killed off the first term, which is x power 4. We have a minus x cubed here. 4x squared minus 2x squared. We have a plus 2x squared. Bringing down the plus x. This is what you learn in high school, actually primary school itself. So now to get an x cubed term, I put a minus x. We have a minus x cubed minus x squared minus 2x minus, open a big bracket. So upon subtraction, what do we have here? We have 3x squared plus 3x. And next we got to bring down the a here. We have a plus a. And then I have a plus 3. So once I get a plus 3, 3 times x squared, we have 3x squared plus 3x. 3 times 2 gives me a plus 6. And then a minus. Notice that the x squared and the x term has cancelled off each other, giving me a remainder of a minus 6. But I know my remainder must be 0 because this guy over here, my divisor, is a factor. So therefore, make your remainder equals to 0. And we obtain a equals to 6. So that is how we get the value of a over here. And over here, guys and girls, find the other quadratic factor. The guy up here, this is your other quadratic factor. So this is the other quadratic factor. Just like this is your other factor, because 2 times 4 give you 8. So these two guys, when you multiply, you will get what is inside when you replace x equals to 6. Is this clear? This is just a short question over here. Any questions on this? All right, so moving on to the next one. This is factor and remainder theorem. They're given us x minus 2 is a factor and divided x plus 1 minus 6. Find the values of a and b. Typical question again involving simultaneous equations this time. So the polynomial here, f of x, is denoted given by 2x cubed minus 5x squared plus ax and plus b. Two conditions given here. We got x minus 2 as a factor, and we have over here x plus 1 giving us remainder equals to minus 6. So if it's a factor, jangan lupa songsangkan, common mistake. We cannot put in the factor. We must put in the root. X minus 2 equals to 0, x equals to 2. So we must input. That means we get f of 2 gives us 0. A factor will have 0 remainder. So gantikan semua x dengan 2 di sini. Replace all the x with 2 giving us 2. 2 power 3 minus 5 into 2 power 2 plus with a into 2 plus b, and that has to equal to 0. 2 power 3 is 8. 8 times 2 is 16. Minus 2 power 2 is 4 times 5, 20. Plus with 2a plus b equals to 0. Therefore, we have got 2a plus b. Bringing over the numbers, 20 minus 16 equals to 4. Call this equation number 1. As usual, by now you guys and girls already know, you do not know two things, a and b, you must have two equations. The number of equation and the number of unknown must be the same. What's the other equation we can obtain? The remainder. We know that when we input negative 1, because again, don't forget to reverse, x plus 1 over here equals to 0, x equals to minus 1, and by inputting x as minus 1, we have a remainder of minus 6 over here. So we have got 2 minus 1 cube minus 5 into minus 1 squared plus with a into minus 1 plus b, and this time it equals to the remainder, which is minus 6. Minus 1 cube is minus 1. Minus 1 times 2 is minus 2. Minus 1 squared is plus. Plus 1 times minus 5 is minus 5. Minus a plus b equals to minus 6. So leaving the algebraic terms on the left hand side and bringing over the numbers to the right hand side, we have got 7 minus 6 giving me 1. So we call this equation number 2. And this could be solved by elimination again, because I see we've got a b. So I take number 1, of course I minus number 2 here. So 2a minus minus a giving us 3a, b minus b is 0, 4 minus 3, 4 minus 1 is 3. So a equals to 3 over 3, which equals to 1. Once I know a, it's easy. I just got to take a and put it back in here. So we get minus 1 plus b equals to 1, giving me b equals to 2. Therefore, we have the answer a equals to 1 P equals to 2. Clear, guys and girls? So the thing that you guys got to pay attention here, the number of unknown must equal to number of equation. Kalau you tak tahu A, B dengan C, you mesti bentukkan tiga persamaan yang melibatkan A, B dan C. In other words, you have to build three equations involving A, B and C over here. So I'm going to take this off. And then moving into the next question. So this is a bit longer. As you guys can see, we've got part 1, part 2, part 3. And we've got an inequality here. Very interesting, the part 3 over here for number 8. So we have Px is going to be given by, we have an unknown in the equation here. 2x cubed plus with ax squared minus 4. And we also know that x minus 4, x minus 2 in this case. We know that x minus 2 is a factor. So again, what does it mean if x minus 2 is a factor? Kena cari root. Mesti cari punca dulu. Punca is called the root. And then we put into the equation. So x equals to 2. That means, in other words, we have p of 2 must equals to 0. So 2 power 3 plus with a into 2 squared minus 4 equals to 0. 2 power 3, 8 times 2, 16 plus 4a minus 4 equals to 0 over here. And then we have 4a equals to minus 16 plus 4 is going to be minus 12, giving us minus 12 divided by 4 is minus 3. So we can take a is minus 3 and put it back into here to obtain the actual equation for px, which is 2x cubed minus 3x squared minus 4. So once we obtain that, they ask us to factorize the px. Untuk pemfaktoran ini, we don't have any choice. We've got to do the long division. And if our answer is correct, we must get the remainder as 0. So let's move on to the next page to do the long division. And let's see if it corresponds. So let me just put that 2 minus 3 minus 4. So we have got 2x cubed minus 3x squared plus, don't forget there's no x term, and then minus 4. When we do long division, don't silap do long division with your root, but with your factor. This is your factor x minus 2. So you divide by x minus 2 over here. So I want to kill off the 2x cubed. I put a 2x squared here. So we have 2x cubed minus 4x squared. Do not forget, as usual, open the brackets. 4 minus 3, I've got x squared plus with 0x here. So to get an x squared, I'm going to get, what do we have here? I've got x. So we've got x squared minus 2x. Open bracket. Minus and minus give me a 2x minus 4. To get a 2x, I need to put a plus 2 here. 2 times x is 2x. 2 times minus 2 is minus 4. As expected, we get remainder 0. Now, when we get remainder 0 over here, it also tells us another thing. It tells us that jawapan A ni adalah betul. Kalau you buat pembagian panjang, you do the long division and you did not get 0, please go back and check. That means your A value is wrong. When you divide by a factor, you must get a 0 remainder. So since it's a factor, we can say now that my px equals to x minus 2 multiplied by the quotient, this guy up here, 2x squared plus x plus 2. Okay, now we're going to the inequality, and they're saying to justify your answer. So I'm going to change the page, and then let's clear this. So we want to solve p of x lebih besar daripada kosong, bigger than 0. So p of x minus 2 over here into 212, 2x squared plus x plus 2, and we want to make this greater than 0. Let's just look at this guy over here now. Let's find out what the b squared minus 4ac for this is. So this is 1 power 2 minus 4. A adalah 2. C is also 2. So I get 1 minus 16, which is minus 15, less than 0, no real roots. So meaning this guy you tak boleh pecahkan lagi. You cannot further factorize the quadratic guy. And you notice one thing, this is a positive 2. Positive 2 means it's a smiley face. So if I were to draw the graph, this is a smiley face and tiada punca nyata. It has got no real roots. That means it's a graph terapung. It's a floating graph. Before it reached the x-axis, it already terbalik already and pusing balik up there. What do you notice from this graph, guys and girls? This graph is always bigger than 0 because it never touched the x-axis. It's always above 0. Dia di atas paksi x. And I want to solve the whole thing to be greater than 0. That means I can safely say this is always positive. Apa nilai yang saya gantikan dalam graph quadratic ni, I'll get a positive value. So for the whole thing to be positive, I want this guy also to be positive. Only then I get positive times positive. We also get a positive. So we already safely know that the guy in the bracket, the quadratic is positive. I need this guy also to be positive. Positive bermaksud greater than 0. So the inequality is x has to be bigger than 2. Any question from this? You got to get this concept clear. We want the two bracket multiplied together bigger than 0. And we know one bracket is always bigger than 0 because the graph belum sampai paksi x, it already pusing. So just pastikan factor, the other component there is bigger than 0. And then we can get the solutions over here. Okay, so you guys are clear with this. And then we move on to solving inequalities. And this one we can just skim through very fast because it's not going to take too long over here. You are the modulus on both sides of the equation. You're going to square both sides of the equation. So we move on to this page. So number 9 over here, we've got modulus 2x plus 1 is less than modulus x. When we have modulus A is less than modulus B or even more than, we remove the modulus, we could just square both sides. Because modulus also is positive, and I square also, I must get a positive value. So therefore, we can safely say that 2x plus 1, the whole thing squared, is less than x squared. Expand the brackets, we have got 4x squared plus 4x plus 1 is less than x squared. Bringing over, we have got 3x squared plus 4x plus 1 and less than 0. We try and find the roots over here. we've got 3x and x, 1 and 1. 3 and 1 is 3x plus 1x is a 4x, and I want to be less than 0. Now guys and girls, we need to sketch this. Jangan buat macam persamaan, ini adalah ketaksamaan. So you need the baseline. We have an x-axis here. Punca yang lebih kecil adalah negative 1, and the bigger root is minus 1/3. Look at the sign here. Ini sangat penting, kita nak lebih kecil daripada kosong. So this is your 0 level. This is smaller than 0. This is above 0. I want smaller means I'm looking for this part over here. So what do we have? When we combine the interval, we have minus 1, x, and minus 1/3. All clear with this? And then the next one, number 10, is also going to be the same. This is quite fast, it's just inequalities, but I'll just do the solution quickly so at least you guys and girls can refer. We have modulus x plus 1 greater than the modulus of x. Again, we square both sides of the equation. Expand the brackets, x squared plus 2x plus 1 greater than x squared. When I bring over, I already killed off the x squared term. So in this case, we got 2x plus 1 bigger than 0. If it's not a quadratic, we solve as usual. We get 2x is greater than minus 1. So the solution set is all the x values greater than half. And then the last inequality question, I'll also do it pretty fast here. It's just the number 3 that is a common mistake here. The 3 in front of the modulus, students usually forget to square that. So in this case, we have got modulus x minus 2 greater than 3 into modulus 2x plus 1. So over here, when we square, we have x minus 2 squared is greater than, we got to square everybody here, 2x plus 1 and square here. Now this is an important step because common mistake is students forget to square the 3. Bila buka kurungan di sini, this becomes 3 power 2, 2x plus 1 power 2 like that. Why? Because hukum index AB to the power of n, when you open bracket, become an b of n. So we have over here x squared minus 4x plus 4. It's going to be greater than 9. And expanding the bracket here, we've got 4x squared plus 4x plus 1. $36x squared plus 36x plus 9. So you got to bring all over to one side. We've got 35x squared and then minus or plus 40x, and what's that going to be? Plus 5, right? When I bring it over there, I get less than 0. So everybody can divide by 5 here. We get 7x squared plus 8x plus 1 less than 0. This looks like we can factorize. because 7 and 1 can give us an 8. So we got a 7x here, x, 1 and 1, plus 7 plus 1 give me a plus 8. As usual, just draw a number line, and we've got the roots here. What are the roots? The smaller root is minus 1, and then minus 1 over 7. We are looking for less than 0, bahagian bawah, and then when we combine we get minus 1 in the interval of x to 1 over 7 is the solution set. So that's just a quick recap on modulus inequality. Any questions on this? Clear? Going on to partial fractions now, which is number 12. This is back to something you guys and girls did not have in your add maths. Especially number 1 is quite long over here. We've got a repeated factor coming up. Can hear? Okay. So the question was, why put a square at the beginning? Now, because it is equivalent. Modulus x is always positive. Okay. Now, x squared is always positive. So they will share the same solution set. In other words, okay, let me show you what a square does. Let's take some time off to explain this. This is one of the interesting parts of mathematics, where if you've got equivalent functions, we're also going to get the same set of solutions. Let's say I want to solve for x plus 1 divided by x minus 5 greater than 0. I'm just making up this question here. Okay. So to be greater than 0, I need a positive divided by positive, or I need a negative divided by negative. So both these will give me a positive answer, which is greater than 0. I'm going to show you how division can also become multiplication in a bit. So if I were to draw a table here, I have x plus 1 above, x minus 5 below. And then we go by the roots. The smaller root is -1, the bigger root is 5. Saya nak isikan, I want to fill up this table now. So pay attention. First, I'm looking at this guy. This is the column on the left-hand side of -1. Any number on the left-hand side of -1 is smaller. Any number smaller than -1, let's say I put x as -3. -3 plus 1 is -2. I get a negative. Any number between 1 and 5, I input as x. Let's say I put 4. 4 plus 1 is 5. I get a positive. Any number bigger than 5, I get a positive. So this is the first guy I'm looking at. Second, I want to look at the denominator, this guy over here. Any number smaller than -1, I put inside, I get a minus. Any number smaller than 5, this is still the left-hand side of 5. Let's say I put 4. 4 minus 5 is still a -1. Any number greater than 5, let's say I put a 6, I get a positive 1. Now look at the operation here. This is divide. So I'm going to divide. That means there's a division here. Negative divide by negative is positive. Positive divide by negative is negative, and plus divide by plus is positive. So I'm interested in bigger than 0. Why? Because the question said it's bigger than 0, and bigger than 0 is a positive. So positive is on the left-hand side of -1. That means x is smaller than -1. Or the next positive is on the right-hand side. Sebelah kanan nombor 5. Sebelah kanan means nombor-nombor semakin besar, getting bigger than 5. So this is the solution set for this. Another way to solve this, I can just change this thing to become multiplication, like just now how the modulus I can square. I can just multiply x plus 1, x minus 5 greater than 0. I can solve for this, I'll get the same answer. So watch over here, if I draw a line, this is my x-axis, smiley face graph. Kalau kembangkan dapat positive x squared. Punca lebih kecil is -1, and then this is 5. So again, I want this guy here greater than 0. Greater than 0 is this side and this side. So if x is smaller than -1, or the right hand side, x is greater than 5. How did a division become multiplication and give me the same number? Actually, when I divided, I can't simply divide something. I have to change it to an equivalent fraction. What I did over here is x plus 1 divided by x minus 5 is greater than 0. Now, equivalent fraction means it's like this. 1 over 2, if you times up and down by 2, is the same as 2 over 4. So what I'm going to do here, I'm going to times up and down by x minus 5. So I get x plus 1, x minus 5. And the bottom, I get x minus 5 we have x minus 5 into x minus 5 greater than 0. But what happened to the bottom over here is, I just take this off over here, x minus 5 and x minus 5, when I multiply, I get a square. From here, the question becomes x plus 1 divided by x minus 5. See, the bottom got two same bracket. Two same bracket means I can just write one bracket and a square on top greater than 0. Now you see there's already a square down there. Since there is a square, I don't need to consider the bottom guy anymore. This guy is always positive. So I just need to make sure the top is positive, because only positive divide by positive. The down is positive, the top must be positive, so I can get greater than 0. So I only deal with the top. So you can see this is another way of explaining the modulus. There's a square. The square in this case is equivalent to also looking for the positive. Same thing with the modulus. Since both sides is positive and a square is also a positive, I'm maintaining the same answer. Are you clear with this explanation? It's equivalent. Okay, so that's done there. So now we move on to the partial fractions. So first partial fraction, tengok soalan je, you must know which category this falls under, how to split the denominator. If you don't know how to start the question, you can't even proceed over here. So look at the denominator for this question. We've got 4x. We got a repeated factor down there. 3x plus 1. And we've got x plus 1 with a square here. If you want to break this up into partial fraction, this becomes a over x plus 1. 3x plus 1 plus with b over x plus 1. And you're going to turun until you reach the x plus 1 squared. So this will become x plus 1 squared. So whenever there's a square outside, this is the way you do it. You keep going down until you reach the square. So if there was a power 3 here, you go until d over x plus 1 cube. But usually you won't get until power 3. I'm just showing you. So that's the way of splitting when you got a repeated factor. Now how do we find common denominator? Untuk cari common denominator, sentiasa kena tengok soalan asal. Look back at this guy. This is the common denominator. And look at your A. A sudah ada 3x tambah 1. So A already got 3x plus 1. What is A missing? A don't have x plus 1 squared. Tambah with, look at B. B already got a x plus 1. What is B missing? B is missing a 3x plus 1. And B is also missing another x plus 1 because the denominator over here in red is x plus 1 squared. B only got 1x plus 1. And C, the denominator over here already got x plus 1 squared. So C don't have a 3x plus 1. So just tambah what C don't have and equals to the numerator over here, 4x. Now our task is to find our A, B, C. Of course, first we do elimination. By looking, I know when x equals to minus 1, I can kill off a few unknowns. A will hilang, A will disappear. Minus 1 plus 1, 0 times A is 0. Your B so will disappear. We can eliminate. Minus 1 plus 1 is 0 and there will be B. Put in minus 1 into your C. 3 times minus 1 is minus 3 plus 1 giving us minus 2C. And put in x is minus 1 here. 4 times minus 1 is minus 4. So this gives us C equals to 2. So we already got our value for C over here. And then I also can kill off another term by letting x equals to minus 1 over 3. Because when I put minus 1 over 3, my B will disappear. Minus 1 over 3 times 3 is minus 1. Minus 1 plus 1 is 0. 0 times anything is 0. So B goes away, C goes away, my A will be there. So I will have A into minus 1 over 3 plus 1 is going to be 2 over 3 with a square equals to 4 times minus 1 over 3 is minus 4 over 3. When I square over here, I get 4a over 9 over here equals to minus 4 over 3. Both sides I got 4, I can cancel off, multiply the 9 up there. So minus 9 over 3a we have as minus 3 over here. So we already got my C, we already got my A. To find my B, I already cannot kill off any other term. I only got two roots. I got minus 1 and I got minus 1 over 3. I can choose to put any value, but choose a small value. Don't make the numbers too big. So I just put 0 inside. So 0 plus 1 is 1. 1 times A is A. I put all my x as 0. I get plus B and then I get plus C. 4 times 0 is 0. We already know my A is minus 3. B I don't know, C I know is a plus 2 equals to 0. So we get over here B equals to 1. Therefore, we have 4x divided by 3x plus 1 into x plus 1 squared equals to A is minus 3, B is 1, and we've got C as 2 over x plus 1 with a square over here. So that's the partial fraction part. Any questions? Okay, now there are SEM2 students over here, right? Can you just give me a thumbs up or any SEM students, SEM2 students here? Okay. So I'm just going to proceed to the SEM2 students here, the integration part of this. Why is this important in semester 2 is, you see here, they're going to ask you to integrate the function. Ini bukan macam pembezaan SPM. So when they ask you to integrate your f of x, nampak tak soalan di sini, dia suruh integrate limit 0 to 1 f of x dx. What is our f of x dx? That means dia suruh buat pengamiran 0 sampai 1. F of x is 4x over soalan tadi. 3x plus 1 into x plus 1 squared. Tetapi this expression kita tak boleh buat pengamiran. We cannot integrate. And that is why in the first part we already did the partial fraction. What I can integrate is the partial fraction, which is minus 3 over 3x plus 1. And then what was the answer? Plus 1 and 2. So plus 1 over x plus 1 and plus 2 over x plus 1 squared. So SEM1 guys and girls, application, where you're going to use your partial fraction. If you don't do your partial fraction, you're not going to be able to do the integration here. So when you integrate this guy over here, this becomes ln. You have not studied this in your Form 5. You'll be seeing it in your differentiation. So this you would get minus ln 3x plus 1 plus ln into, but the log part you guys got to pay attention because log is part of the syllabus. And this you bought like your Form 5 lah, the inverse chain rule. So you'll get minus 2 over x plus 1 over here and masukkan limit. It's a show question. Jawapan sini you nak tunjuk jawapan is 1 minus ln 2. So masuk the upper limit. We put 1 in there, we get minus ln 4 plus ln 1 plus 1 is 2 minus 2 over 2 is 1. Minus with masuk 0. So we get minus ln 1 plus ln 1 minus 2 over 0 plus 1 is minus 2. Now you guys, SEM1 guys also got to know this. Ln 1 is 0. If you press calculator, so because e power 0 is 1, dia adalah songsangan daripada index. So bila buka kurungan, nampak tak? Negative and negative jadi positive. So 2 minus 1 give me 1 minus ln 4 plus ln 2. So this is 1, factorize the negative. If I take out the negative, I get ln 4 yang 2 pula jadi negative. And what is the hukum log here? What is the property of log? Ln, when I divide, when I minus will become divide. So this become 4 divided by 2. This one you had in your add maths. So when I open, I get 1 minus 4 divided by 2 is 2. So I get 1 minus ln 2. There you go. Sudah tunjuk jawapan. So when you get the answer in your part 2, you already know your partial fraction in part 1 is correct. If your partial fraction is wrong, surely you cannot show your integration is correct. Is this clear? So ini sikit dah masuk dalam SEM 2. Just a little bit, but the partial fraction is all your SEM 1 work over here. And then we're going to the next part here now. Also, number 13 is partial fraction. Cuma the expression here is different now. So we want to find the partial fraction for 3x over x plus 1, x minus 2. So this is paling senang, the easiest. We just put a over x plus 1. And if you follow carefully, guys and girls, for this topic, actually just by the example, you already can learn the whole topic. It's not too technical like number 14, where we're going to go into double angles and trigonometric identities. So when we want to do the partial fraction here, we just cross multiply because we got two linear factors. Simple, like what you have learned in your maths during high school. And this got to be the 3x over here. So since this is 3x over here, I want to kill off my b, so I let x equals to minus 1 here. So b will be gone. I have minus 3a equals to a minus 3, giving us a equals to 1. I want to kill off my a, so I put x equals to 2. 2 minus 2 is 0. So 2 plus 1 is 3b, and 3 times 2 is 6. So I get b equals to 2. Lepas dah dapat a dengan b ni, don't forget, gantikan dalam pecahan separa. Oleh itu kita perolehi 3x over x plus 1, x minus 2 equals to 1 over x plus 1 plus with 2 over x minus 2. Now we're going to go a little bit into the next part. Okay, the next part, read carefully. Without evaluating any constants, they just want to see you pandai tak pecahkan that into partial fraction. So over here, guys and girls, what's going to happen? Move on to the next board. This one we tak payah cari A dengan B. Dia nak tengok bentuk je and then you get the full marks. So always read the question. Some students don't read the questions, they'll do the whole partial fraction. That's just a waste of time. So how do you break up 4x over x plus 4, and the other guy is an irreducible quadratic, x squared plus 3. What is the bentuk arm for this, the general form? So the x plus 4 is linear, so up there is a constant, a. Now the x squared plus 3 is a quadratic, so up there is linear, bx plus c over, because yang bawah tu adalah quadratic. The top guy is always 1 power less than the bottom denominator. That's all they want to do for part 1 of bahagian A. Then we got 2x plus 1 divided by, we have over here x minus 2, x plus 2 squared. So ini same macam tadi kita dah buat. This is repeated factor. So we have got just pecahkan a over x minus 2 and then plus b over x plus 2 plus with c over the x plus 2 with a square. Then we are done. And this one just masuk a little bit for the SAM 2 students over here. We want to integrate from 3 to 4. 3x over x plus 1, x minus 2. And we want to show, this is another show question, it is equal to ln 5. So to integrate this guy again, we cannot integrate this form. We must integrate the partial fraction. So partial fraction tadi we got 1 and 2. 1 over x plus 1. So we got 1 over x plus 1 plus we got 2 over x minus 2. This is the first part earlier. Again, once it's linear down there, when we integrate, we're going to get ln. So this guy, we get ln x plus 1 plus with 2 ln x minus 2. 3 to 4. As usual, what you did in SPM, masuk the upper limit, we get ln 4 plus 1 is 5 plus 2 ln 4 minus 2 is 2 minus with ln 3 plus 1 is 4 plus with 2, 3 minus 2 is 1. I can see we already got the answer because this hukum index is hukum log is your SAM 1 work. 2 ln 2 saya boleh tulis sebagai ln 2 power 2. Kuasa boleh naik. And minus ln 1 is 0. Just now I told you guys. See what happened? This is ln 5. This become ln 4 tolak ln 4. 0, forget about it. So we already show. They asked to prove it is ln 5 and we got ln 5 over here. Clear, guys and girls? So next we're going into a long trigonometric identity over here. Now the trigonometric identity over here, you see the cos 4 theta, you know that's a bit tricky already. Let's put this question up. Now there are many ways to do trig identities, but if you know your identities well, you could do it faster. If you take the long route, sometimes you come back to where you started, you know. So we want to prove that sine power 2 theta. So you got to recap a lot of your double angle formulas which you have done in your form 5. This is 1 over 8. And for students who want to do engineering, I cannot stress how important trigonometry is, because you're going to do a lot of trigonometric differentiation, and trigonometric integration is out of the world. It's not easy. So for this question, I'm going to choose, I would choose left hand side. I can directly see a double angle formula because I've got sine squared theta into cos squared theta. I'm going to rewrite this as sine theta cos theta. I'm going to go step by step so you know it's equivalent. Same thing, I can put the square here. Sine squared cos squared, I can put sine cos and then I can square outside the big bracket. Why? Because it's multiplication. If it's sine squared plus cos squared, I can't do that. Now what I'm going to do, I'm going to make this as 2 sine theta cos theta, and I'm going to divide by a 2. So note, guys and girls, I have not changed the question actually. Sebab atas ada 2, di bawah ada 2, I can cut the 2 and 2, I still get back sine theta cos theta squared. Why I put a 2 up there? Because if you observe, 2 sine theta cos theta is your double angle formula for sine 2 theta. And then down there I've got 2, I just put a square here. So sekarang saya buka kurungan. I can rewrite this as sine squared You can rewrite it as a sine squared 2 theta. And don't forget 2 power 2. Bawah sana, the denominator becomes 4. Now we go back to a bit detail on double angle. Cos 2 theta ada 3 jawapan. One is cos squared theta minus sine squared theta. Another one is 2 cos squared theta minus 1. And then another one is 1 minus 2 sine squared theta. Okay. The same thing applies for cos 4 theta. Double angle formula bermaksud kalau di sini 2, semua sudut di sini is 1. You see this is 1 theta, this is 1 theta, this is 1 theta. So if I put cos 4 theta, this will become, you look at the third line, ini akan menjadi 2 sine squared 2 theta. That's all. In other words, if I tell you cos 10 theta, it becomes 1 minus 2 sine squared 5 theta. That is why it's called double angle formula. From here, I'm going to make sine squared the subject. So sine squared 2 theta, I pindahkan ke sebelah kiri, I get 1 minus cos 4 theta. And then I bahagi 2. So sine squared 2 theta equals to 1 minus cos 4 theta divided by 2. So now what I'm going to do, guys and girls, I'm going to rewrite this. I'm going to rewrite this as 1 over 4 times with sine squared 2 theta. Same thing, I'm just writing it differently. And sine squared 2 theta, saya gantikan dengan this expression. So, I will get 1 over 4, open bracket, 1 minus cos 4 2 theta, everybody divide by 2. If everybody divide by 2, 2 ni saya boleh bawa keluar. If I take out the 2, 4 times 2, I got the answer. 1 over 8 into 1 minus cos 4 theta here. So you see the importance of knowing your double angle well. Most of the time you use cos 2 theta, but they can ask you what is cos 4 theta, they can ask you what is cos 10 theta. I mean, this is Stpm. They're going to make it crazy hard, but if you know the basics pretty well, no problem. Whatever question they give you, you can go around it because you know your identities pretty well. Any questions on this? Okay, seems to be no question on this. Next, we're going to, okay, the next question, number 15, I put it on here because, okay, I guess the recording will stop here. So that's mainly because of the space we have to upload on YouTube. But what you guys and girls can do, we will upload the recording later on. You can screenshot my solution. I mean, most of you guys got a smartphone anyway, so just take a picture and then you will know the solutions to it. Okay, so later you can refer. So now I'm going to go on to number 15 over here. Number 15, there's a very common error done by students, and I'm going to show you what that is. Very, very common. In SPM pun sama, Stpm also same. So just keep reminding yourself not to make this common mistakes. So you want to solve this equals to cos x